Hey, this is Mr. P, and today we're going to learn about Newton's third law. So first, most people have a version of this, which is something like for every action there's an equal and opposite reaction, and there's nothing wrong with that version of this rule, but I don't think it's the most clear or straightforward version either, because there's a lot of people that can say that rule but don't have any clue what it actually means. And so I actually prefer a mathematical definition. And I know that sometimes math can be scary and intimidating, but in this case, I think it makes this idea very clear, simple, and straightforward, at least as much as possible. So the version that I prefer is a force on A by B is always equal to another force that goes in the opposite direction, which is the force pair, which means it's on B by A. And so if you find two forces, one where it's in the form on A by B, and then the other one that's on B by A, then according to this rule, they have to have the same size and they have to point in opposite directions. That's what the minus sign says. So those are force pairs, or you could say they're Newton's third law force pairs. And this rule is always true. There's no exceptions. It doesn't matter if it's moving at a constant speed, if it's sitting at rest, if it's accelerating, if it's on Earth, if it's not on Earth. It doesn't matter. If it follows this pattern, it's always true. But one thing that you got to be careful of is that sometimes students use this rule when it doesn't actually apply. So if, for example, there was three objects, so if it was like on A by B and then on B by C or something, then that wouldn't follow this rule. It's not in the same pattern. It's got to be A and B on A, the same two objects flipped around exactly like this. Otherwise, the rule doesn't say anything. So it's really important that you check and make sure, does the rule actually apply before you try to use it? But if you do and it follows this pattern, then they had to be equal. So let's see if we can apply this to a situation. So let's say we have a bus, and the bus is kind of in a hurry, and so we're going at 200 kilometers per hour to the right. So there's a bus, and in the path of the bus is a fly, and the fly is going at 1 meter per second to the left, and they collide, and I think you'll agree that the fly splatters on the windshield of the bus. So my question for you is, how does the force on the fly by the bus compare to the force on the bus by the fly? Please pause the video and take a second to think about it. Well, the first thing we need to do to figure out if we can compare these forces using Newton's third law is to figure out, are they actually force pairs? So let's write it out. The force on the bus by the fly, and we're trying to compare that to the force on fly by bus. Well, you can see this one says bus and then fly and bus. They're flipped around, so they are force pairs, which means they do follow this rule, which means they have to be equal in size. But that can be kind of counterintuitive because it seems like the effect on the fly is a lot different than the effect on the bus. And in this case, I do agree that the effects are not the same. So if we think about what was the initial velocity, let's make a chart of like velocities of the fly and the bus before and after the collision. So if we think of, for the bus, the initial velocity was 200 kilometers per hour, and let's make to the right positive. And I think you would agree, after the collision, so I'm going to call that final, the bus is basically going to be going the same speed as before, maybe just slightly slower. So let's say that afterwards the bus is going 199.99 kilometers per hour. Seems pretty reasonable to me. And then if we think about the fly, at the beginning it was going at minus 1 meters per second. I'm saying minus, sorry, this should be kilometers per hour. Bad units. Let's just cross that out. km per hour. So the fly was going at minus 1 kilometers per hour because it was going to the left, and afterwards it stuck to the windshield of the bus, which means that it is also going 199.99 kilometers per hour. And so the collision for the fly took the same amount of time as the collision for the bus. And so you can see how the change in velocity for the bus is really small, and the change in velocity for the fly is really big. So the fly had a much greater acceleration than the bus. And so then the question is, how can I claim that the force between the fly and the bus and fly is the same, even if the effect or the acceleration is very different? And well, I can claim that because there's another factor at play here, which is inertia. So the bus has a lot more mass than the fly does, and so all that mass requires more force to accelerate it. And so even though it's the same force or the same cause from the bus to the fly and vice versa, the effect or the acceleration is very, very different. And so the acceleration of the fly is obviously way, way bigger than the acceleration of the bus, even though the forces, because they're force pairs and by Newton's third law, are the same. Okay, thanks for watching.